I'm Doug Fernan. This is my take on music recording. This is part 2 of 3 parts about magnetic tape recording. Last time, we reviewed some of the characteristics of the magnetic tape recording system. Now we are going to look into some of the details of how tape machines must be maintained in order to work well. This is not a tutorial on tape machine alignment, which is rather complex, but rather an overview to give you a sense of what's involved. All tape machines have mechanical adjustments to precisely position the magnetic heads in all 3 axes. Most of these are set at the factory when the machine was made and are generally stable enough to ignore for daily maintenance, except for the azimuth adjustment. That is the precise angle between the tape passing by and the tape head rotation in the vertical axis. This should be exactly 90 degrees, but how do you set that? And why does it change? Well, the heads are being worn down all the time. Tape is like fine grit sandpaper. As the metal of the head wears down, the azimuth can change. To set the azimuth, you need a reference calibration tape, which you have to buy. A 1/4-inch reference tape is less than $200, but a 2-inch tape could cost well over $1,000. Another thing you need to be aware of is that tape heads slowly become magnetized just through their routine operation. A magnetized head is like an erase head, only in this case it gradually erases the tape every time the tape is played. It's subtle, affecting the highest audio frequencies first. Fortunately, it's relatively easy to remove this magnetism using a tool called, not surprisingly, a head demagnetizer, or sometimes called a head degausser, which is the same thing. It uses an electromagnet that is powered from the AC mains, creating an intense magnetic field that comes and goes 100 or 120 times a second, depending on the mains frequency in your country. The demagnetization procedure is simple. You simply move the head demagnetizer up to the recorder playback head and let it do its magic to destroy the residual magnetism in the head. But it has to be done properly, or you can do more harm than good. You can even totally magnetize your heads if you aren't careful. That can be undone, but that needs to be recognized and fixed before you use that tape machine. I won't go into the details here, but just follow the instructions that came with the head demagnetizer to the letter, and you will have perfectly demagnetized heads in a few seconds. The tape machine must be turned off for this procedure, and keep any tapes at least a couple of feet away from your demagnetizer so you don't erase a valuable tape. Because the tool will do that, or add a lot of noise to your recording. Some machines have a control that must be set before demagnetizing the heads. This prevents damage to the electronics, even when the machine is turned off. You should demagnetize the heads every week or so, just to be safe. And always, before you thread up your expensive alignment tape. Okay, back to our azimuth adjustment. The reference tape is recorded with precision so that the recording signal azimuth is exactly 90 degrees to a small fraction of a degree. The tape also has various other tones on it for adjusting your tape machine. But it all starts with the azimuth. This tone is typically 16 kilohertz, since the need for precision increases with frequency. When we adjust the azimuth screw on the playback head of our tape machine, we are tilting the head slightly from side to side. The 16 kilohertz tone will peak on the VU meter when the head azimuth matches the reference tape, that is, with a mono tape machine. With a stereo tape machine, you not only have to peak the 16 kilohertz tone, but also look at the phase difference between the 2 channels. The phase has to be perfect, or your recordings will have a phase error that will be a problem if your recording is heard in mono. and even a problem in stereo if the phase error is bad enough. Note that the head that is badly out of alignment may be so far off that it's possible that you are looking at different cycles of the alignment tone on different tracks. That will drive you nuts trying to get the adjustment right. So it is good practice to first adjust the azimuth at a lower frequency, where the cycles are farther apart, just to make sure you are close to proper alignment. You might start as low as 1 kHz and gradually work your way up to 16 kHz, checking the adjustment along the way. So why is this important? Phase errors are frequency dependent and can mess up your stereo image and stability. And of course, the tape will not be mono-compatible. You might think mono-compatibility is not an issue in the 21st century, but there will be times when your work will be heard in mono, and a phase error in mono will ruin your great recording and mix. The phase accuracy is even more challenging with a multi-track tape machine. Maintaining precise phase coherence across a 2-inch wide tape is next to impossible, which is why, if you are recording a stereo pair of tracks on your 24-track machine, you better have those tracks adjacent to each other. Azimuth adjustments on a 16 or 24-track machine involve a lot of compromises and a sense of how you are going to deploy different instruments on various tracks. If they're all mono tracks recorded separately, no problem. Any stereo tracks, or bleed between tracks in the studio, will need to be precisely in phase to sound right. We have several methods of determining the phase relationship between the tracks. The conventional method uses an oscilloscope. One channel is displayed on the vertical axis, the other channel is displayed on the horizontal axis. When the channels are perfectly in phase, the oscilloscope will display a perfectly straight, very thin, diagonal line from lower left to upper right. You may have a phase meter on your digital audio workstation, and that will work too. In fact, many phase displays will emulate the oscilloscope pattern, although some, for reasons unknown, show an in-phase condition as a vertical rather than diagonal line. Whichever, the result is the same. A totally out-of-phase display will be a perfect circle. You want the perfect line with no bulge to it. Some DAWs have a phase meter that displays phase as a deviation from a centered meter needle. And, in a pinch, you can get pretty close to perfect phased alignment by monitoring the two tracks with both panned to the same point in the stereo image and reversing the phase or polarity of one channel. When perfectly in phase, the result will be perfect cancellation of the tone, which you can see on a meter that monitors a mono sum. The meter will show no signal at all. You might even be able to do this by ear if your hearing is good, but it's difficult to do at 16 kilohertz. Okay, now we have the playback azimuth set to match our reference tape. Next, we have to set the playback level so the desired playback level reads 0 VU. But what is standard level? Well, this is something you have to decide and make standard for your studio. The level is specified in nanowebers per meter, a measure of magnetic flux, or, more simply, the magnetic strength transferred to the tape. Over the years, this level has crept upward as better oxide formulations were developed for tape. This allowed higher levels to be recorded, which reduces the noise level. There's a lot to this, and setting the reference flux level has many implications for how the recording will sound. A very conservative standard is 250 nanowebers per meter, but it could be as high as 300 or 500 nanowebers. 380 nanowebers is another common reference level. Helping you to decide what you want your tape to sound like is beyond this brief introduction, but it is something you should investigate before deciding which level you want to use. When you order your alignment tape, you will choose between the various flux levels offered. We play the 1 kHz reference tone on the tape and set our playback meter to 0 VU with a level calibration control. Next, we set the high frequency EQ with its trim pot on the electronics for that track. This is easy. Just set the 10 kHz tone on the tape to match the 1 kHz tone from the tape. But check the manual for your tape machine because the high frequency adjustment frequency may be different. Some machines have an additional adjustment for low frequency equalization. Do that for each track. Now the playback system of your tape machine should be right. But note that if you plan to use different tape speeds for different projects, you will have to repeat this procedure at each speed, except for the playback head azimuth, which should be the same at any speed. You will need another reference tape if you plan to use different speeds. 15 and 30 inches per second are probably all you will ever use. Oh, and one other set of adjustments on some tape machines calibrates the sync playback. You will need to do this if you plan to do overdubbing. It's not necessary on a 2-track machine. When overdubbing, the record head is temporarily used for playback, so the new recorded track will be in sync with the existing tracks. This feature was originally called Cell Sync by Ampex, but later it was shortened to just Sync. I'll talk about overdubbing and bouncing tracks on another show, but just be aware that you may need to repeat some of the playback adjustments for the sync playback. Well, we're about halfway done our routine alignment. Next, you have to set the record system of the machine to match the playback we just aligned. First, put up a new reel of the type of tape you use. You should standardize the tape formulation that you want to use in your studio. This doesn't mean you can't use other tape types, but each tape formulation will require a new calibration of the tape machine. The record alignment will require a setup oscillator of some sort. The first adjustment is the record head azimuth. But wait, why are there separate record and playback heads? And which is which? Well, the main reason there are 2 heads is because each is optimized for its function. You can use the record head for playback, and this is necessary for overdubbing. It won't sound as good, but it's fine for reference. As you look at the head stack on your tape machine, from left to right are erase, record, and playback heads. You record your azimuth tone of 16 kHz while monitoring the playback. Just as you measure the phase difference between the 2 or more tracks during the playhead alignment, now you will do the same while adjusting the record head azimuth. Across 2-inch tape, it's never perfect, but think about how you are going to use those tracks. Now we come to the record bias adjustment, which is critical to the sound of the machine. There are several ways to do this, but the easiest and most common way is to feed a 10 kHz tone at reduced level, -20 works on most machines, or maybe -10, and adjust the bias trim pot for that track until the signal peaks, and then go beyond the peak until the level drops by 2 dB, or 3 dB, or more. It depends on what the tape manufacturer specifies and the sound you like. Make sure you're on the high side of the bias peak. Then adjust the record high-frequency EQ trim pot so that the 10 kHz and 1 kHz levels read the same on the machine VU meters. There may be other adjustments on your machine, for low-frequency EQ, for example. Repeat this for all the channels. There is another way to adjust bias, which I prefer, and I think improves the sound enough to be worth the extra time and effort. First, you have to get a ballpark adjustment using the conventional method just described, but just adjust the bias for a peak in the 10 kHz output. This approach requires some good quality audio test equipment, specifically a very low distortion sine wave oscillator and an audio analyzer that measures total harmonic distortion. But we won't pay much attention to the distortion reading on our audio analyzer. This method uses your ears. It requires an analyzer that has an analog audio output that you can listen to. Feed that analyzer output into your control room monitor speakers. You need high-quality speakers to make this adjustment. Put a 50 Hz pure sine wave into your recorder at 0 VU level. Most audio analyzers work by nulling out the fundamental tone, in this case 50 Hz, and measuring whatever remains. We are listening to the whatever remains part, which consists of the harmonics of the tone plus all the trash and noise that is left. It does not sound pleasant, but you have to listen to it at a reasonable level as you adjust the bias control for the track you are adjusting. As you increase the bias, the noise and other trash will start to diminish and will null at some point. Crank up the monitors a bit more so you can hear what's left. Now, adjust the bias for minimum annoyance. Kind of vague, I know, but there's no other way I know to explain it. When you reach the optimum point, you'll know it. Then complete the other record adjustments for the track and move on to the next one. Ooh, that took a while no matter what method you used. And your machine is now perfectly aligned for that reel of tape. No matter how good the tape manufacturer is, there's going to be differences from reel to reel. If you buy your tape in bulk, you might get away with using the same alignment settings for all the reels in that batch. But you can't depend on that. And that's why every reel you use has to have its own set of reference tones on it. This isn't too difficult. At a minimum, 1 kHz and 10 kHz will do. This will be a check of the machine bias and EQ settings for that reel and provide alignment reference for the mastering facility. If there is a significant difference in response, say more than 1 dB, then you should do the record bias and record EQ adjustment procedure. The azimuth adjustment is pretty stable and only has to be checked every week or so on a machine that gets lots of use, and even less frequently for a machine that is seldom used. The azimuth changes as the heads wear, so the total hours of operation is the key factor. If you want good, consistent results from your tape machine, this is what you have to do. There are many more adjustments on a tape machine, but these are the day-to-day ones. Every model tape machine is slightly different, so use the frequencies, levels, and indication that the instruction manual specifies. And then there's ongoing maintenance. It's a mechanical device subject to a lot of wear, and some parts have to be periodically replaced or refurbished. The record and playback heads, for example. Tape is abrasive and constantly wears down the metal of the heads. Eventually a groove is worn in the head, which causes a loss of high-frequency response, an inability to set azimuth, and even poor tracking as the tape catches on the sharp edges of the head. Tape heads can be ground back into shape, a process called lapping, performed by a specialized shop. This can be done a couple of times before the heads are too worn to restore, and then you will need to replace them. This can be a major expense with 16 or 24 track heads. There's some good news, however. The erase heads seem to last forever, and erase heads do not require routine alignment. The capstan pressure roller will eventually lose its proper dimensions and consistency and need to be replaced. And even the capstan shaft itself will eventually wear down and or lose its surface properties and need to be replaced. On older machines, this means rebuilding or replacing the capstan motor. Everything the tape touches will eventually wear out. If you can feel the groove with your fingernail in any head or guide or capstan, it's past replacement time. And one last note on maintenance. Every day before you thread up a reel of tape, the tape path must be cleaned. On an all-day session, this will be necessary several times. The heads, guides, and capstan and roller need to have all traces of oxide from the tape removed. What you use to do this depends on the tape machine manufacturer's recommendations. But on most tape machines, a cotton swab with isopropyl alcohol is acceptable. Failure to properly clean the tape path will result in a loss of high frequencies, lower levels, and eventually all kinds of problems with the tape tracking through the heads and guides. This is my take on music recording. I'm Doug Fern. See you next time.